Okay, let's be real. Have you ever opened up LeetCode, seen the hundreds and hundreds of problems, and just felt totally lost? Yeah, you're definitely not alone. It's a rite of passage for anyone prepping for a coding interview. But what if I told you there's a much smarter way to do this than just grinding away, problem after problem?
This right here, this quote is the secret sauce. This is the whole key to unlocking LeetCode. It's about shifting your mindset away from just memorizing solutions and towards understanding the fundamental patterns that solve entire categories of problems. You're not building a checklist, you're building a toolkit. And that's the big question, right? That's exactly what we're going to break down today. We are going to unpack the most important patterns that will completely change your problem-solving game, giving you the confidence to walk into an interview and tackle a problem you've never even seen before. So here's our game plan. First, we'll talk about why this pattern-based approach works so well. Then, we're going to open up our Coder's Toolkit and look at some must-know patterns for arrays, linked lists, and even trees and graphs. And finally, we'll reveal the whole set of tools you need to really feel like you've mastered this.
You see, the magic of learning patterns is that they give you a blueprint. Instead of seeing a new problem and just freezing up, you start to spot clues. You'll think, this looks like a job for the sliding window pattern, or this smells like a two-pointers problem. And that ability to identify the right tool for the job, that's exactly what interviewers at places like Google and Amazon are looking for. All right, let's start with arrays. They're everywhere, right? So we're going to look at two super powerful patterns that can take your array solutions from slow and clunky to lean and incredibly fast. First up is a true classic, the two-pointers pattern. The whole idea here is to get rid of those slow, brute force nested loops. Instead, you use two different pointers or indexes that cruise through the array, saving you a ton of time. A perfect, simple example is checking if a word is a palindrome. You stick one pointer at the very beginning and another at the very end. You look at the two characters. Are they the same? Cool. Move both pointers one step closer to the middle. If they're ever different, boom, you're done. It's not a palindrome. This simple trick takes you from a potential O(n)² solution down to a blazing fast O of n. That's a huge win. Next up in our array toolkit is the sliding window. This one is fantastic for any problem where you need to look at a continuous chunk of elements, like finding a subarray with the biggest sum. Now here's the clever part. You don't recalculate this sum of the entire window every single time it moves. No way. You calculate the sum of the first window. Then, as you slide it one spot to the right, you just subtract the number that fell out of the back and add the new number that just came in the front. It's so much smarter, and it drops the time complexity from O of n times k all the way down to O of n. Okay, so that's arrays. Now let's switch gears to a totally different beast, linked lists. These problems are all about skillfully manipulating pointers, and wouldn't you know it, there are some really elegant patterns for that too. This next one is almost like a magic trick. It's called the fast and slow pointers pattern, and it's exactly what it sounds like. You have one pointer that moves one node at a time, that's your slow pointer, and another that jumps two nodes at a time. That's the fast one. I love this analogy. Just picture two runners on a circular track. It's just a matter of time before the faster runner laps the slower one, right? It's guaranteed. Well, in a linked list, if that fast pointer ever lands on the same node as the slow pointer, you've just proven without a doubt that there's a loop. This is also the secret to finding the middle of a linked list in just one pass. It's brilliant. Another super common task is reversing a linked list. Now, you could just dump all the values into an array and read it backwards, but that costs you extra memory. The real pro move is using the in-place reversal pattern, which just rewires the pointers that are already there. The trick is this little three-pointer choreography. You have previous, current, and next. And in every step of your loop, you first save where you need to go next. Then you tell your current node, hey, instead of pointing forward, point back to the previous one. And then you just scoot all three of your pointers one step down the line. It's a methodical little dance that reverses the whole list using basically no extra space. All right, now we're moving up to the big leagues, trees and graphs. When you're dealing with these, pretty much everything boils down to how you travel through them. And the two absolute cornerstones of traversal are depth-first search and breadth-first search.
So let's break this down simply. Depth-first search, or DFS, goes deep. It dives down one branch as far as it can possibly go before it backs up and tries another. It uses a stack to keep track of where to go next. Breadth-first search, BFS, goes wide. It checks out all the neighbors at its current level before moving on to the next level down. It uses a queue. So here's a huge tip. If a problem ever asks for the shortest path, your brain should immediately scream BFS. If it's more about exploring all the possibilities, like solving a maze, DFS is probably your go-to.
Okay, so we've covered the absolute fundamentals. But to really become a pro, we need to add a few more specialized tools to our toolkit. So let's quickly run through some of the other patterns that will really round out your problem-solving abilities.
And now our toolkit gets really powerful. You've got things like top K elements, which almost always involves a data structure called a heap. There's overlapping intervals, which is absolutely essential for any kind of scheduling problem. And then there's backtracking, the powerhouse pattern for when you have to explore every single possible combination or path. Each one of these opens up a whole new world of problems you can solve.
And that brings us to the one that scares everybody, the final boss, dynamic programming, or DP. But listen, don't let the name intimidate you. At its heart, DP is just a really clever strategy. It's about solving a giant, complex problem by first solving all the smaller, easier versions of it. And this is the key, remembering the answers so you never have to calculate the same thing twice.
And guess what? Even this final boss can be defeated by, you guessed it, recognizing patterns. Learning to see if a problem fits the structure of the famous 0-1 knapsack problem, or if it's the longest common subsequence problem in disguise. That is how you conquer DP. It all comes back to the same core skill. So if you only take one single thing away from all of this, let it be this. Stop counting how many problems you've solved. It's a vanity metric. Instead, focus on deeply, truly understanding these patterns, because one pattern can instantly unlock the solutions to 10, 20, even 50 different problems. That is how you win the LeetCode game. So, the only question left for you is, where are you going to start? Take a look at this toolkit. Find one that feels like a weak spot or it just looks interesting and go deep on it. So, which pattern are you going to master first?